Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. So in this video we are going to learn about diffusion constant and Einstein's relationship. So Einstein's relationship. These are the concepts which we are going to learn in this video. Okay, if you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so what is a diffusion constant? So first point which you have to remember is diffusion constant is a material constant. Okay, so it is a material constant and it is responsible for diffusion, for property of diffusion in semiconductor. Okay, so diffusion constant. So how the electrons are going to be diffused. Okay, right. Second, Einstein's relationship. So what does this Einstein's relationship gives is it gives the relation between, so this diffusion constant is represented by D. Okay, so if it is for electron, it is represented by Dn. If it is for hole, we'll represent with dp, similar to mu n and mu p. So it gives the relationship between d and mu. This is very important point. So what does Einstein's relationship gives you is it gives the relationship between d and mu. Okay, so it is given by dn by mu n is equal to dp by mu p is equal to kt by q, which is equal to Vt, which is equal to T degrees Kelvin by 11,600. Okay, so this is the relationship. So here Vt is equal to T degrees Kelvin by 11,600. This is very important. So this Vt is called as volt equivalent of temperature. Volt equivalent of temperature. Okay, so it is called as volt equivalent of temperature, and K is Boltzmann constant. Okay, so K is Boltzmann constant. So K is Boltzmann constant, which is given by 1.38 into 10 to the power of minus 23 joule per degree Kelvin. Okay, so K is this, right? So volt equivalent of temperature. So how this voltage, right, depends on temperature. Okay, so for applied voltage, so there will be drift, and how this voltage and drift is related is given by volt equivalent of temperature. So the important point which you have to remember is at room temperature, at T is equal to 300 degrees Kelvin. So what is the value of Vt you have to remember. So Vt is given by 300 because temperature in Kelvin is 300. So 300 by 11,600. So it is approximately 26 millivolts. This value is very important. So at T is equal to 300 degrees, Vt is equal to 26 millivolts. Next, fourth important point which you have to remember is Vt is proportional to T. That is, as temperature increases, volt equivalent of temperature also increases. Okay, so at T is equal to 0 degrees Kelvin, that at absolute temperature, so Vt is equal to 0 volts only, because T is equal to 0, 0 by anything is also equal to 0. At T is equal to 300 degrees Kelvin, so Vt is 26 millivolts. So for high range of temperature variation, there is only small variation in Vt. Okay, so this is the relationship which you have to remember. And fourth, say dn is equal to Vt into mu n. Similarly, dp is equal to Vt into mu p. So these are the formulas for dn and dp. Okay, so Vt into mu n, because dn by mu n is equal to Vt, so dn is equal to Vt into mu n. Similarly, dp is equal to this. So what are the units now? So this is fifth point and this is sixth point. So units of diffusion constant. So what are the units for Vt? It is volts, right? So because it is volt equivalent of temperature, so it is volts. What is unit for mu n? So we have seen that it is meter square per volt second or centimeter square per volt second. So this volt gets cancelled off. So units are meter square per second or centimeter square per second. These are the units for diffusion constant. Okay, so seventh point which you have to remember, very very important, the values of diffusion. So it again depends on mu n. So because Vt is almost constant, so it again depends on mu n, and since mu n decreases with increase in temperature, dn also decreases with increase in temperature. This is one of the important point. So dn also, as temperature increases, dn also decreases because it is depending on mu n again. Okay, so the seventh point which you have to remember is values. So at T is equal to 300 degrees Kelvin, so dN dP, this is for germanium and silicon. So this is 99, 47, 34 and 13 centimeter square per second. So these are the values of dN and dP for electron and hole in the case of germanium and silicon respectively. Okay, so these values you have to remember at 3 is equal to 300 degrees Kelvin, or you can always derive at the same time. So Vt we know that at T is equal to 300 Kelvin, so it is 26 millivolts, so 26 into 10 to the power of minus 3, right? So mu n value we know, so it is equal to 3800 for germanium. So mu n value is 3800. So if you solve this, you will get around 99 only. Okay, similarly for mu p in the case of germanium and mu n mu p in the case of silicon, also you can derive like this, or instead you can just remember like this. Okay, so these are the important points which you have to remember with respect to diffusion constant. Okay.